Most phenomena in physics and engineering can be modeled with polynomials. But what exactly is a polynomial, and why do we study it? A polynomial is an algebraic expression formed by adding terms, each consisting of a coefficient multiplied by a variable raised to a non-negative integer exponent, meaning, only whole number powers are permitted. For example, 2x to the power 3 plus 3x squared minus 5x plus 7. The degree of a polynomial is the highest power of its variable. So x squared minus 5x plus 6 has degree 2, that makes it a quadratic polynomial. These degrees tell us the nature of its graph, straight, parabolic, or cubic. Zeros are simply the x values where the polynomial becomes 0, where the graph crosses the x-axis. For example, y equals x squared minus 3x plus 2 has zeros at x equals 1 and 2, because y equals 0 when we substitute x with either 1 or 2. For a quadratic, a, x squared plus bx plus c, the sum and product of its zeros follow a simple pattern that directly links the roots to the coefficients, making factoring and problem-solving easier. The sum of zeros equals minus b by a, while the product of zeros equals c by a. Let's solve a real example. We factorize x squared minus 5x plus 6 to get x minus 2 times x minus 3. So, zeros are 2 and 3. Their sum is 5, which equals minus 5 by 1, and their product is 6, which equals 6 by 1. It matches perfectly. In this video, we covered what polynomials are and how zeros are linked to coefficients. In the next video we'll explore the division algorithm and how it simplifies polynomial factorization and solving polynomial equations.